Okay, so here's the example of a multiple linear regression that we did in class. And as you remember, this is the car mileage data set. And we have, let's see, so we have miles per gallon, cylinder, for each of these cars. I think we sampled something like, 390 something, 393 samples. And from each of those cars, we took a miles per gallon, the number of cylinders, the engine displacement, horsepower, the weight of the car, and then how long it took to accelerate to a certain speed, the year of the car was made, and then the origin of the car. So in this go around, we're going to sort of not use this origin, but next class we're going to figure out how to use it. As you can see, that it's a categorical data, so it's a little bit more tricky to use it, but we definitely can. So we'll do it in next time. So here we go. So miles per gallon is what we're trying to predict. This is according to the problem, we're some consumer group, and we're trying to figure out what drives miles per gallon of these things. And so that's what we're doing. So miles per gallon is our y, and then the rest of these guys are our x's. So in Excel, if we're going to do this multiple regression, all the x's have to be next to each other because we're going to highlight them all. Okay, when time comes. So we have to do this with the data analysis toolpack. Click on regression. Choose our y, so our y is this miles per gallon, right? So if I choose the very top and then hit Control Shift down, we just select it all. And then our x's, so x's I can start with cylinder, hold the Shift button down, and then click my arrow to the right, all the way over, so one at a time to the year, and then hit Control Shift and hit down, right? And then it selects everything all the way down to the bottom. So that's what we want. Click on OK. I have a label, I want a confidence interval, and then where do I want it outputted? Well, let's see. So click in here, and then I'm going to say put it right there. See, right now it's going to be screwed up if I click OK because it has both of these. If I click it again, then it'll be right. I have residuals checked. Yeah, let's just keep it checked. We can look at it and see what's going on. So that's it. So click on OK. Alright, so we discussed all of this stuff in class, what all of this output looks like and what it means. But I'll quickly go over it again just so that we can have another review of what's going on here. So this time in class I started at the bottom and went up, but this time I started at the top and go down. So of these ones, what we're interested in is these r squared and adjusted r squared. And this tells us the proportion of the variability of our y that's explained by our model. And adjusted r squared adjusts for the number of variables, because we can actually sort of game the system of the r squared by just adding more and more variables. It will always go up. But adjusted r squared adjusts for that. So in this case, they're actually really close to each other, so we're not too concerned with that. So that's good. So we have like an 80, roughly 80, round up 81% of our of the variability in y hat, or variability in miles per gallon, can be explained by these 6 variables, by our model that we have right now. Okay, so that's good. The other ones is multiple r is just the square root of r squared, and then standard error we're not going to use right now, but really it's just the sort of the average error that we see. And then this is the number of observations that are taken. So next we have this Anova. Remember, Anova just gives us the overall significance of the entire model. So it's sort of the first round check to see if the model is significant at any level. And the null hypothesis is something like, at least, sorry, none of these variables, none of our variables are significant, or essentially all of these variables equal 0. It's kind of the same thing. That's the null hypothesis, so that nothing interesting is going on. Remember that all of these equal 0. And then the alternative hypothesis is that at least one of these does not equal 0, or that is, at least one of these is significant, does not equal 0. And we have a really low p-value for that. So that means we should sort of gives us a thumbs up that we go ahead. We reject the null hypothesis that says that none of them are significant, and assume that at least one of them is. Okay, so that's good. So that's all we care about. This one is this guy. This is a p-value, even though it's a significance f. It's a p-value. So next we come down here and we have intercept and all our variables. And then these coefficients. So the coefficients, the first thing we see, these are the b's, right? These are the b's that we are after. And so we have these numbers. So with these we can kind of create a formula, right? So, and it would look like something like negative 14.53 minus 0.329 times cylinder plus 0.0076 times engine displacement minus 0.00039 times horsepower minus 0.00679 times weight plus 0.0852 times accelerate plus 0.75 times year. Right? So this is sort of great big formula. And we'll show in a second what we can do with that. These other numbers are all things that we're kind of understand what's going on as well. So here's the standard error and T-statistic. So this is stuff that we've done before, where we could go and figure out, we can assume that these are sort of from a sample, right? And we can kind of treat these as if they're sample means. They're not exactly like that, but that's what we've been dealing with, is sample means, and we've been able to figure out what a standard error and a T-statistic is for some sample mean. Right, if we knew the sort of the proportion or the distribution of what's going on there, and we have some hypothesis. Well, this is pretty much exactly the same thing. So each of these rows, so like this row, that's another one. Here's another row. Each of these rows has its own hypothesis test going on, right? So there's like 7 hypothesis tests going on right here, and it looks something like. Well, we can sort of write it out. So it looks like, let's see. It looks something like, intercept equals, let's do it this way. Yeah, this guy, and then I'll put this in quotes, equals 0. Is it going to work? I have to put an and sign in here, and there we go. Intercept equals 0. So that's the null hypothesis. The alternative hypothesis is intercept, and then put and then this guy's does not equal, oops, in quotes, does not equal 0. Whoops. Does not equal 0. Alright, so that's, let's make this a little closer here. So there's our null hypothesis, and here's our alternative hypothesis. Right, and that's what's going on. So we actually, the same thing is happening for all of these. I copy these down. So, right, it's exactly the same thing. So there's all this many number of hypothesis tests going on, right? And they're all the same form, right? So our null, the nothing interesting is going on, is that it equals 0. And why is that important? Well, if it equals 0, then there's, if you think about from the simple linear regression, that means there's no slope. There's no use in even having this because we can't really use it to predict our y. So there's not a lot of reason that we have it there. This means that there is some type of slope. Like there's some reason to keep those things. So that's what's going on here. So here we have a standard error and a t-statistic. Remember, t-statistic is just the number of standard deviations away from the expected mean. Our expected value. Our expected value is 0 in this case, and that this 14 is 3 standard deviation negative, 3 standard deviations away from 0. Right. So from that we calculate a p-value. And we have a real small p-value in this case, which means if we have a p-value less than some alpha, and we would probably say less than 0.05, we would reject the null hypothesis, reject these null hypotheses in favor of these ones, right? And say, well, okay, the intercept must actually be bigger, and then we would say that it is significant. Right, so this one looks like it's significant. So this is the intercept. Again, we don't care too much if the intercept is significant because all it means is that it's not 0. Okay, that's all this is saying. Well, we don't care if the intercept is 0 or not, but it does the test for us. The ones that we really care about are these guys, right? The rest of them. So let's look through those. So it looks like the only one that's significant is that guy and that one. Right? The rest of these are not significant. Or that is that they don't have a low p-value, so we couldn't reject the null hypothesis. But this we would say weight and year are significant variables when it comes to predicting miles per gallon in our model right now, our current model. Okay. So the other thing that's kind of interesting to show is these confidence intervals. I'm not sure why it gave me 2 confidence intervals. That's a little bit weird. I wonder if I had these left over from like the last time that I did this. Probably. Let's just delete those. Yeah, so we get these confidence intervals. Confidence intervals around our sample statistics. So these coefficients, you can think of these as sample statistics. And how do we calculate a confidence interval? Remember, it's just some sample statistic plus or minus some margin of error. And the margin of error is some multiplier times some standard error. The multiplier in this case is a t, and this is 95%. So we find some 95 percentile for the t, multiply it by standard error, and then add and subtract that to this coefficient. We come up with these confidence intervals, so it does it for us. The only thing that I think is kind of interesting in this is that these, you can see right away that these ones that are not significant, so these three right here, if you look at their confidence intervals, these are lower and here's our upper. Well, it straddles 0, right? It goes from negative to positive, negative to positive, negative to positive, which means that 0, which is our null hypothesis, is inside of our confidence interval. And that is just another reason, that's another explanation of why this has a high p-value, right? And so this guy over here, where it is significant, it's not in there. Same with this one, not in there, right? So this does not straddle 0, they're both positive. So that's kind of another way to think about what the p-value is giving us, right? So we're not certain that this number is not actually 0, right? So we build a confidence interval. Here's one, this one. So this one is not actually 0. Build a confidence interval and say, well, we're pretty certain, 95% certain that the true value of this, or this is just a sample, the true value of this, the true population parameter of this cylinder, so what we would call beta, is between these two numbers. Well, 0 is in there, right? And so because of that, we cannot say that the number we found is actually significant, meaning that it's not 0. Could be 0. Okay, so that's that. So the final thing, again, of these residuals. So again, it went and calculated y hat for every single one of these. So let's see, let's copy these guys up. Let's see if I can do this. Insert copied cells, shift cells, right, yes. I didn't like that. Let's try again. Insert. Paste those guys. Okay, so what's going on here? So remember, this type of miles per gallon is, we would put all of these numbers. In fact, let's do it. Let's just, I'm going to copy this, and I'm going to kind of come down here. Let's see, just do it over. Or should we do it right here, maybe? And I'm going to paste these, and I'm going to transpose it. So that means it's going to flip it on this side. So I'm going to, how I did that was I go to paste special, or if I go to paste, this little thing right here is a transpose, right? Or if I click on paste special, you can say click on transpose right here, and transposes it, which just moves it. Before it was vertical, now it's horizontal. The reason I wanted it that way is because I'm going to multiply it by these guys with the sum product, right? And find out what my predicted value should be. So in fact, we'll call this what? Y hat. So how do I do that? Well, I say what I say, just like my equation would be, I'd say this intercept plus, and we did this in class, sum product of those guys, multiply and add by these guys, right? So remember, sum product, all it's doing is taking the first one and the first one here, multiplying them, and then adding it to the second one times the second one, plus third one times the third one, plus fourth one times the fourth one. It's just going through exactly what we want, what the formula would look like. Click enter. So this is our y hat for our very first observation. We should have gotten 15.08929. So that's what this is right here, right? So there's that same number. So it's actually just gone and done that for us for every single one of these. That's what these predicted miles per gallons are. And then figured out the residual, which is just the error, the difference between what actually was and what was predicted. So actually, we got 18, but we predicted 15, so the residual was 2.97. So we're going to use, again, we're going to use these residuals in next class to figure out whether or not certain conditions are met that are appropriate. Okay, so that's it for this one.